Hello everyone, we are meeting with my new project called Cinematch. So this is a content-based movie recommendation system I created using a small data set to just study and learn how the system will works, and the data processing part and the things. Okay, first of all, I will show you a small demo here. We can search for any kind of image, any kind of film, because I have used a small data set. There are a small number of data. If we can use big data set in movie data set, we can develop this system into to very professional level. So as example, I will search a small like this. So if we search like this, we can this the system automatically recommend the similar kind of movies to us. So we can filter like this also, top 5 movies, and we can search for top 20 movies, and like this we can search. So this is the basic thing I have to show in my demo. So let's move into our workflow. That means I have the model training part and the data processing and other things, and after that I go to the UI and UX design part, this small design, and for the deployment. So first of all, I would like to show you the data processing part, that means the model training part. So let's go to the Visual Studio. So here you can see the screen. So first of all, I will explain this briefly. First of all, I have imported two libraries, Pandas and NumPy. So we are using the numbers and the NumPy. As we are using arrays here, I have imported the NumPy library. So after that, I have get the movies. There are in here we are using. I have used two kind of CSV files. So I have imported them, and as we have to read them. So I have get a small print here, the movies.head, that prints the head part of the that CSV, and the ratings.head we can see. Okay, after that process, I have go for this cell final data set equal ratings.pivot. So here this line reshape the your rating data from a long format so into matrix. From that means the rows show the movies and the columns are showing the users. Then the rows are showing the movie IDs and the columns are showing the user ID. So basically it turns the when we are using this cell, this code, basically it turns the data into a user item rating matrix. So which is the foundation for the collaborative filtering and similarity based recommendation. Okay, so that's why we are using it here. So when we are considering this one, the original rating, the you can see the final rating here. So there is a user ID and the movie ID. User ID means you can see there is the user ID and the movie ID. Then this is the ratings that they have given. That means I have using two data sets. In the rating file, there are some movies didn't get ratings from some users. That's why they are calling not a number, NaN. There is a like this. So that's why uh, that's the point. So I will I will explain that point after this one. So here we have turned into the user item rating matrix. So after that, I have print the final data set here. It looks like this. After the final data set, I have go for the another part. So here I would like to explain. I have used the pivot function to create a user movie matrix with where each row represent a movie and each column represent a user. The cell values are the ratings given by the user to that movie. Okay, this is structure me to compute the similarity between movies based on the user ratings. So we are going to recommend a movie. So this structure allow to compute the similarity between the movies based on the ratings that the user have given. So that's why I have used this one here. So final data set, then I have final data set here. You can see that. So here not a number, all the numbers I have equal to 0 because there is not, because that users haven't voted to those movies. So that's why I have using this one, final data set dot fill in plus so equal true. So here I have convert this NaN value, all NaN values to 0 because we can't use that values to train our model. So that's what I have done here. So after that I have used this one. So I am going to explain that part now. So here this is getting the what this coding do, counting how many ratings exist per movie and per user. So here we are going to get count how many ratings exist per movie and per user. So here we are getting the idea about how many ratings. That means one user gives how many ratings and the one movie gets how many ratings from the users. That's what we have counted here. After the counting process, so this help to understand the data quality. And also when we are considering this one, before the building our model, this part help to understand the data quality. Some movies or users may have to few ratings because some users haven't rated any kind of movie. That data is not important to us in this data set, so we have to clean them. That's why we are using like this. So we are going to get a threshold value here. In the other part I will show you. Here I have plot this one. If we want to plot a graph, we have to import the matplotlib library. So I have also installed that one here, pip install matplotlib. After that I have plot this one. Then I have get the threshold value here. You can see in the 10. This is the cutoff region. So after my training process, the green line marks the 10. You can see it's about 10. So what this one do, the green line marks your cutoff region. So anything below will be removed from my training data set. That's the thing here we are going to do. In here. We can see the final data set. After that cleaning process, the number of row has reduced. So here you can see, here we can see 9724 rows here. So after the cleaning process, there are only 2121 rows here because I have cleared the movies that haven't get any kind of ratings and the other things. Then after that one also I have considered about the users that have not given the proper ratings and the rating count. Where here I have get about the idea of the rating count, and I have get a threshold value. After that we have cut off that unnecessary data from our model training part, as we have to get for more efficiency, because we have to get users and movie IDs that are frequently used. After those process I have only get here you can see rows and columns. So there are final data set shape. You can see 2121 rows and 378 columns we have used in here. So this is our final data set. Here you can see all the numbers, so we can go for the training process. This is the data set for finally. So final data set we can see like that. Then for this one, the sample equal np.array. This is a sample one. I will explain this one. So there are, I have creating a small matrix to represent a user movie rating. So there are user movie rating. So and after that calculating how sparse, how many values are missing or zero. There we are trying to get how many values are missing or zero. So there are zero values. So in here this is just like an array. Consider like an array, or consider like a matrix or something. So 1 0 0, and this row will go like this, and there are each row means a user, each column means a movie, and each value is a rating. So there are bindu 0, so that's calling the 0 means that they haven't given a rating for each movie. That's user ID did not have given any rating for that movie. So there are so after the calculation there is a small function sparsity equals 1 minus number of non-zero entities divided by total entries. So this is the function. So then we have get the sparsity of 1.8. that means high sparsity. That means there is a high sparsity close to 1, means most of users haven't rated most movies. Then we can get the idea, because we have get a closer value for 1, so it represent means the most users haven't rated most movies. So that's the point we have to get. We have to understand that if the value is close to 0, that means you have the dense data, many ratings. So every user has give the ratings. That's the point. So if we are consider real world example, imagine data set with 10,000 users and 5,000 10,000 users and 5,000 movies. That's the 5 million possible user movie pairs. There can be 5 million possible user movie pairs, but in reality only a small fraction, like 1 to 2 percentage pairs have ratings. That's the thing. So that's why we are recommending the system to need for smart algorithm like KNN or something. So after the get the idea, we have moved to that part then. Okay, before the going for that part, we have to do a small process. That's what we have done here. You can see that code will convert our dense matrix. So there are zero values which we don't need to use. So compressed sparse row, CSR means compressed sparse row matrix, which is memory efficient format for sorting large dataset. So here we are using this one. Then it will be give the values codes is like the positions. 0 0 value is 1, so 1 2 2. So 0 values, the matrix 0 values will be cut off from this one. So this is the data processing part. So this part we use that to save the memory. That's the point. So the importance of this memory efficiency and the speed, the mathematical operations, we can do the mathematical operations very speedily, because we are using the less memory data set here. That and the other thing is scalability. That means the real world recommended data can have millions of user and items. So dense matrix would be too large to store. That's why we are using like this here. So after that one, we have print CSR data, and from this one we can move to the other part. Here I will explain this one now. From Scikit-learn neighbors import, here we have used the cosine. So we are building a k-nearest neighbor model that uses combine cosine similarity to find the most similar movie based on user ratings here. So This is a memory based collaborative filtering approach, so meaning it took for pattern directly in the rating data rather than the learning predictive parameters like natural networks do. So first we have from the Scikit-learn neighbors import nearest neighbors. So we have Scikit-learn class knn, we have imported that one. After the processing part, this is where using the cosine metric and the algorithm root. So here I will explain why we are using cosine. I use the nearest neighbor model here. You can see that after filtering the sparse matrix, the model can take any movie and return its top 20 nearest neighbors. Top 20 nearest neighbors. Here we meaning the most similar movie according to user preference. So here we are using cosine. This is the cosine is using in two vectors. We know if the angle difference is small, so the values must be in the similar way. So that's the point there we are using. So after that one, this is the system cosine metric we are using. So I have printed them and the check them also. After this one, the training part, Gradio, I have installed Gradio for Gradio. We are using Gradio Python library that makes it easy to create a web interface. So in here, without deploying, we can get a small user interface here to check that whether our system is working properly or not. That's the point we are using here. I have used that one here. After that I have get output, but here we can use this one without any deploy or something. But if we are going to plan to deploy this was as a web platform, or in future we are planning to go for develop this one and interact with the users, we have to deploy this one. That's the point. So that's why that's when we need to do that one. So we need to get out the model. So that's why after this process I have done that one. So I am using TensorFlow here. I installed that libraries and imported them. So after that process, I have successfully saved my model as a .h5 file. Okay, I have saved my as a .h5 file. Then I have go for my UI UX design part. So that's my data processing part and the data cleaning. After that one, I have save my model as h5.h5 file. So let's move to the other part. I will explain that one with this is my this is the UI UX design part. This is very small interface. I show you that this is the small UI I am using. So here I have using Python for the backend development and the HTML, CSS and JavaScript for UI design. So we can see I will explain this one because I have faced a small trouble here with my model file, because my model file is larger than 100 megabytes or something. It's about 730 megabytes or something. I don't know why I have searched that one, but unfortunately my file was about 130 megabytes. Can show you that one. I will show you. Here's my file. This is about 124 megabytes. That's the point I have faced. So that's why here I will show you web.py here. Kaggle, I have used the Kaggle as here I upload my model to Kaggle and I link that one here. Then when my system is working, the model will be automatically downloaded and my system will work like that. That's the point I have to tell here. So that's the thing I learn from, small thing learn from also here. So I will show the model. So here Kaggle, I have uploaded my model. I will show you models. Here your works. So this is the thing I have I have uploaded here. So now there are 15 downloads also. Today I uploaded this one. So this is the thing. So I have Kaggle and link that one. I will show you in the code also. There here you can see. After that so UI design I use the HTML and CSS for styling and the JavaScript. Okay, that's the small thing. So this is the UI button. I have to explain one thing, that's the deploy part. I can show here, right? So in the deploy part there was an issue because I deploy this using the Heroku. I will show you that one also. When I am using the Heroku, because my model is larger than 100 megabytes or something, there was a small error I have faced because the this is not supporting the RAM. We are getting the RAM capacity around 512 MB or something for the for free package. So for free package I was unable to deploy this one. I was unable to deploy this one. Unable to deploy this one because of the low RAM capacity. Because of that, I need the big capacity now, big RAM capacity of my deploy site. So because of that, I have to for pay little money and get the echo package. I get that. I will show you here in the resources. Here I Dynotype, I got the basic one, because also we can use the echo one here, because my file I show that one, my file is about 724 megabytes. That's why I don't know why, as I am studying, I haven't any idea about why this get this large much, but I will study that one also, how to reduce this one. And my last model training parts, I didn't get this one because they were very small ones. But here I don't know why. Did anyone have the idea? You can help me in the comment section. So this is and then I go for basic plan, but this is so good and my recommend system is working well and no any crashes or something. When I am using the free one, there was some crashes because when I am working on this one, when selected 20 I recommend, the system was crashed. So that's why I go for a plan to just for study purposes also, just a try. So this is my system, and I briefly explain all the things I have done here, and the model data cleaning part and the deployment part also, and the data, all the things I have learned from this one as a researcher about machine learning and other things. Okay, so this is the thing I have to show you today. So thank you very much for the seeing my video, and thank you and have a nice day.